welcome to Turing Dev Talks. This is Love, your host for the day, and I am signing in from Gujarat, India. And on the panel, we have David, a machine learning engineer at Turing, who is joining us from Armenia. David is super skilled in machine learning with expertise in Python, MLOps, data science, Docker, and Pandas, even many more Python libraries. And today we are here to discuss a super interesting topic, machine learning models in production and anomaly detection. Honestly, David, I'm super excited to talk with you. I'm also an ML enthusiast. And so without further ado, let's dive into today's discussion. So first of all, thanks a lot for joining us today and tell us how are you doing? How is your work treating you so far?
Thank you so much for the invitation. It's great to be here. The work is good. We are in the middle of an important sprint, so a lot of exciting stuff going on here. Yeah, everything else is fine.
Great. Okay, so you're doing good so far, and for next couple of questions, first of all, let's tell us how we can so some of the challenges you have faced in scaling up ML models like at production level.
Yeah, I think there are a bunch of challenges when we move from experimentation to proof of concept and to production. The first, I think, family of challenges is connected with data and all the complexities surrounding it. So it's not only the scale of the data that changes at the production level, but also it's the context of data. The data that you have trained your models on might not be very relevant in production if your customer gets to a new market or gets to a new subsegment in or niche in that market, and the data of the incoming customers is not like the data that you have trained your model on. So that's the first a bunch of challenges that can come with the data. Another problem is when you're not using data lake approach and data is stored in different formats, and even the naming of, let's say, columns in pandas can change over time, and that can actually break your models in production. So that's another challenge that can accompany data, and that's why a non-data lake approach and training models on top of traditional data warehouses can be challenging when it comes to production. So strong governance system and data cataloging is required so that the data is shared transparently and gets cataloged well and gets eventually leveraged well in the production stage. Another, I think, important aspect when going to production with machine learning models is the engineering and deployment issues. Most of data scientists start with developing their experimentation in Jupyter notebooks, and the logic in Jupyter notebooks might not be the same logic that you deploy to your production servers, and there are a lot of bugs coming on, and the model can simply just not work on a different software or computational environment or on a different hardware. Also having a standardization, Dockerizing and containerizing your models is an important thing to keep track of and to actually prepare for before moving machine learning models to production. And ML systems can be quite difficult to engineer, and a wide breadth of technology is available in the ML space, and standardizing different technology stacks in different areas while choosing each one such that it will make productionizing harder is also very crucial for your model success. We should be aware of the fact that machine learning code is only more often than not, is only a small portion of the overall code of the system that goes, of software system that goes to production. And there's a lot of integration work that needs to be done to actually have your models talk to the other parts and modules of your software system. So the integration risks are also important to track and to prepare for. The complicated code bases have to be reshaped into more well-structured systems that can be ready to be pushed into production. And again, in the absence of standardized processes, that can also be challenging. So that's another important thing to work on across teams, not only within the machine learning team in an organization, but across different teams that are going to work on different pieces of software. This is also the part where agile methodologies of project development or project management are important in the earlier stages of development, to sync the teams and to have great emphasis on the integration rather than to wait until the release and then find out that something is not integrating with the other parts of the software. After you are in production, then a whole new set of challenges arises, and just successfully deploying the model to production is not the end. It's not even the beginning of the end, but it's just the end of the beginning, if we can say so. So it starts the second phase where you should constantly test your model and monitor its performance. It might be well deployed and work well for a few weeks, but then after several weeks, it might be completely off, and your customers may be maybe going crazy about your model's performance. So monitoring both your data and your model's performance, and here the two important concepts are the data drift and model or concept drift that you need to be aware of and constantly monitor in the production stage. Yeah, this group of challenges is related to maybe to those two important cases. And finally, maybe there's also the human factor, of course, at play. So assigning roles and communication in a proper way is also very important, since different teams are going to work on the project. The data science team, data engineering team, maybe a machine learning team that can be separate from data science team, DevOps or MLOps team, and ensuring a synchronized communication between all of the teams is also very important from the organizational perspective. So taking the models to production, to sum up the answer to your question, requires both technical and communication strategies to be done well.
Yeah, that makes sense. Like if you have good technical skills, but like not that much good level of communication, in that case, you might face some issues while deploying your models to production.
Exactly.
So now you have told us about all the challenges of scaling the models on production. Let's take forward and let us talk around what happens once the models are in production. Let's talk like how models performance get tracked once they are in production, how you track its analysis and metrics.
Yeah. So I've briefly touched upon the concepts of data drift and concept drift, and I think they are really important in production stage. Even before that, you can play with different parts of your data, especially if it's a time series data and or the data is generated at some frequency, whether it's daily frequency, hourly frequency, or it gets generated in milliseconds, or whether it comes every week. You should be aware of how your model performs on different time windows of the data. So if you trained off your model of data that was 6 months old, and then on the last month it's not performing that well, that's a challenge you should be looking forward to, and you should address even before deploying the model to production. But once in production, there is an important thing to look at if your data changes, and it's in real-world applications, it can happen for a number of reasons. The data shift can be abrupt if, let's say, your customer is going to a new market, or is deploying a new product, or is addressing a new age category within the customers, or there is, if there are more hardware projects, there is a new type of sensor that is deployed on the hardware and is collecting a new type of data, or the accuracy that it collects data changes. These are all potential causes in real-world scenarios where your data distributions can change. And being aware of that, if you have trained your models on a different data distribution and now you're dealing with a completely different one, is also very important. So a number of techniques in place, starting from just looking as primitive techniques as just looking at the mean and standard deviation of your data distributions, up to more advanced techniques like deploying data distribution tests, let's say Kolmogorov-Smirnov test, or a bunch of other statistical tests to check whether your data that you're dealing with in production is coming from a different distribution, or whether there is a sudden, gradual, or maybe seasonal change in the data, and adjusting your models or training your models to address the new reality is an important thing. So far we've talked about your, let's say, independent features, if we can say so, your X variables. And it's also very important to be aware of the other concept, the relationship between your X variables and your dependent variable, or your target feature, your Y variable. So that relationship can actually change. Your data can remain the same, so the data distribution can be the same. You're not expanding to, let's say, a new market, or you're not deploying a new product, or you're not upgrading your hardware with new sensors, and your data looks the same, but suddenly your models do not perform well enough. So that the relationship can actually change, and that change can also be either sudden, or it can be gradual, or there can be just some blips in that change, or it can have some seasonal nature, and there are a few other types of the relationship change that you can experience in the real world applications. For example, if you are working with the same cohort of people, and COVID kicks in, and everyone is locked in their apartments, and they were not used to. They still have the same income level. They still have the same demographic features like the age, gender, etc. So your data distribution didn't change that much, but their usage of their credit cards, or let's say they're visiting some recreational spaces, or that those patterns have changed significantly. And this was, of course, like maybe the extreme example of COVID, or an external variable coming in. But in real life, there can be examples like weekends, which can affect your relationship between your X and Y in a seasonal way, or there can be, let's say, annual vacations, or some other, let's say, heat wave periods, and other meteorological, or even social and economic and political, all types of variables can actually impact the relationship between your features that you've used to predict your target feature. And therefore, looking at the concept drift and so how your model's performance changes over time is important. And also checking your assumptions constantly. And in terms of assumptions, I mean, like, if you are assuming that this variable is causing another variable, or is a good predictor for another variable, so checking that correlations and causations is also very important. And looking at the differences in your feature importance list of your model, how it changes over time, is also a thing we constantly do in production mode.
Yeah, so like basically you need to keep training your models. You need to observe them, otherwise like whenever trend changes, you might need to retrain or rephrase your models to get aligned with the current market standards we have. So let's like we had a talk around the ML models, how we will be like testing them. So let's consider a real world scenario. You are an ML engineer in a social media company, and during COVID-19, like as you know, most of the social media users, they have been talking about COVID. Either they are like from biology field, or like they are just random people who just keep talking around that. And due to that, there was a spike in that particular phase. So you know that trend particular doesn't last forever. So that will be a sudden spike, and it will go down suddenly. So from your point of view, you are an ML engineer, and like your data distribution has been changed considerably. Like it was a drastic change, and now you need to retrain your models, or like your models are affected. How would you react or train your models again?
Yeah. First of all, it would be a good idea to have as much stuff automated as possible, because COVID was like an extreme example, but more mild examples are happening on a constant basis. So having a lot of stuff automated, and a lot of retraining pipelines automated. So if let's say you have specified a number of sensors or threshold values on a number of variables, let's say if the distribution changes, if the change in the mean is beyond some specified proportion or percentage. The same goes for other statistical attributes, like the correlation between your X variable and Y, or one of your X's and Y's. If the feature importance of your best predictor drops below a specified threshold, etc. All of that, or just some logic of combination of different factors, triggers a pipeline of retraining your model. Coming back to your example of a real-world scenario during COVID-19, so maybe in that case, some manual work and some work on the data science team can also be necessary. And of course, for MLOps pipeline, if you have a bunch of models in your arsenal that your pipeline is going to try, and it's going to try some hyperparameter optimization on each of the models automatically, and then select the model that performs best on the new data that you are dealing with. That can be one example. But also in many cases, like you need some handcrafted feature engineering on some new features, adding some new maybe stop words or to your vocabulary if it's an NLP model, let's say, or also tracking some other variables like the number of COVID cases in your country that you haven't had before. And maybe for that, you would also need a separate data engineering pipeline that would actually pull the data, get it stored, standardize it in accordance to your standard procedure of dealing with the data, and then integrate it with the model. So your model can see whether, let's say, the number of cases in your country would actually lead with some time lag to spike in the number of, it's sad, but to the number of deaths in the country. For most of the countries, let's say it was 2 weeks between the spikes of the number of cases and the number of deaths for COVID-19 case. And then maybe that number of deaths would actually trigger some different topics and sentiment on social media, and you would need to be aware of that, or your models should be aware of that. If, let's say, you are in a social media company that, or in a marketing company that monitors the social media through machine learning and tries to predict, let's say, what would be the consumption level of a given product, let's say face masks or whatever, then actually adding those extra features like the number of cases in your country that you haven't looked before would actually make sense. So search for new features would be one thing that I would recommend. Automating as much of MLOps pipeline and retraining pipeline would be the second one. But of course, this doesn't preclude the importance of data science teams closely monitoring the arising features and maybe other predictors and adding them to the model, and then pushing that everything to the MLOps pipeline would be maybe my response to that question.
Yeah. So like basically you need to be in collaboration with ML team, data science team, and whoever engineering team that can help you out in that case. And basically your model should be reframed as soon as like there are sudden spikes or any other changes. So you need to pull out the relevant data. You need to train your model according to that. And if not, just let your model know that there is some kind of data that is being changed, and according to that your model can react to that particular situation.
Yeah, exactly. And if I can add one thing on that question, let's say if you're in a social media company and you're tracking, let's say, 5 most trending themes, or whether it's 5 or 15, and then all of a sudden, like all of them are being replaced with the other themes or topics related to COVID-19, that should also your model be aware of. So if your, let's say, dependent variable or your target feature is a categorical variable consisting of those 5 themes, and you are predicting which one would be the most trending one, then you should also give space to your model that there might be 15 another themes or topics that your model should be able to predict across. So not limiting your target feature is also very important.
Yes, yes. So let's take this conversation forward, and like let's talk about anomaly detection. So like model drifts, model retaining, we have talked about, and like there are always anomalies in all the models. Like no model in this world would be a perfect model. So could you shed some light on like what is anomaly detection, and like how do you handle that with ML models?
Yeah. So yeah, I think anomaly and more generally outliers are very important for the field of machine learning in general and for a number of customer-oriented applications. So there are, like, I think 2 main threads of anomaly detection, one with supervised machine learning approach and the other one with unsupervised machine learning approach, or supervised and unsupervised anomaly detection. So in the first case, you have the labels, or you have a label data set where you know which cases are anomalies, and you're basically training your model to be able to classify future data points as an anomaly or not, or a normal case. So like neural networks and various neural networks from deep learning space are used for that, support vector machines, k-nearest neighbor classifiers, the decision trees, and tree-based models like random forest, XGBoost, can actually perform very well on those tasks if it's a supervised learning problem. In case of unsupervised anomaly detection, you do not have the labels, and you only have the data, which can actually make the case more interesting. And your model has to figure out the anomalies on its own. In many cases, there is the risk that the model with fine outliers that are outliers in some sense, but in not in the sense that the business would be interested in. So let's say if you are looking for anomalies, let's say in a bank fraud or those the credit card fraud or those types of fields, and then you identify a transaction case which was an outlier in terms of the frequency or in terms of the amount of money, but it wasn't the actual fraud case, the fraudulent case. So that can be an example where your model can generate false positives or false alarms. But I think that's also the interesting part where the interaction between human experts and the unsupervised anomaly detection methods can actually come into play. So instead of having, let's say, human expert labeling a whole data set of 50,000 or 5 million cases, your unsupervised model or your clustering algorithm can cluster those cases into different clusters. And then you can just look at the cluster centroids and to a very small, let's say 0.1% of cases that are located closest to each of the centroids, and then just send that part of the data to the human expert to label. And then based on that, you can actually propagate those labels and already train a supervised learning model based on that. So this is another interesting hybrid case of having supervised learning, and human experts interact. But if we are talking about purely unsupervised anomaly detection, there are also a bunch of algorithms that can be used for that, like self-organizing maps, k-means, DB-scan algorithm, isolation forest, which again comes from tree-based methods, which actually prove very efficient in different real-life scenarios to be able to identify anomalies.
Yeah, so what would you say, like a real-world example of anomaly detection in ML world?
Yeah. So the first thing I'm thinking about when talking about anomalies in the real world is identifying something dangerous, whether it's fraud or risk, and because whether happily or not, these cases are less frequent than normal cases. Dangerous cases are less frequent. So yeah, one example can be, as I mentioned, like credit card fraud, which has become a textbook example for looking at transactions. Another case of anomaly can be cybersecurity, where you have different requests, and you should identify anomaly requests to be able to protect your system against. In DevOpsSec world, there are a bunch of cases of anomalies. I think anomalies are also interesting for financial markets, where you find an anomalous event, let's say like a war outbreak or some political crisis, and how it will impact the financial markets is a very hot topic to predict in machine learning. Not only in machine learning, but also in like different other areas that train statistical methods, other time series, non-ML time series methods, etc. So it's an important case to look at too. Yeah, also, I think anomalies are important in hardware maintenance, and especially in predictive maintenance, where finding an anomaly, let's say, which can come from a not normal sound coming out from a machine, especially if it's an expensive machine like an airplane or military-grade hardware, and identifying that sound in advance can actually save you millions of dollars in repair costs of that machine. So that is also an interesting case of anomaly that different machine learning and machine learning methods can be used for. Let's say digital signal processing can be used for identifying those sounds, for example, and this is the part where we come to the intersection of machine learning and physics and other sciences to be able to efficiently identify anomalies.
Yeah. So all the ML engineers who are aspiring to be a successful ML engineer, keep in mind that k-nearest algorithm, support vector machine, k-means, c-means, all these are the basics of ML as far as I understand. And you would require this because you would need to find the anomalies and you would need to fix them. So learn them in all the courses, you would find them. So David, now let's talk about what are the benefits. Like we have already talked about what are the methods to detect anomaly. So how it would benefit ML model once the anomaly is identified?
Yep. Yeah, so I think one of the benefits can actually be for identifying anomalies with ML or outliers with ML. The first benefit would be for ML models themselves, because in many cases, the outliers can actually contaminate your data, and it can make it difficult to train your models on. So just identifying outliers and taking them out and training your model on the rest of the data, in some cases can be beneficial. In other cases, you should pay particular attention to outliers. So yeah, that was the first, I think, example. Other more like real life and business-oriented examples would be process automation. So you can have your experts, whether it's a cybersecurity case or whether it's a credit card fraud case, sitting all night and just looking at the incoming data and trying to manually eyeball the anomalies. But you can have either a machine learning model that completely substitutes the experts, or in some systems or in some domains, more realistically, it can aid the experts to identify anomalies. So full or partial process automation is very important to be able to deploy the anomaly automation at scale and at speed efficiently. Another thing is adaptive performance. Your expert might have some skill set and some relevant training to identify anomalies of some set or some class, but your world and your anomalies are changing constantly. So having your ML-powered anomaly detection system be able to self-learn and scale along with the growth of your data as it gets generated, and also using the concepts like data drift and model drift that we have discussed before, and constantly adapt to the new reality, to the new data is important. So the adaptive performance is, I think, the second benefit of having machine learning find anomalies and outliers in your case. And in many scenarios, this can actually lead to simpler system handling. So if you have an automated system and you have a systematic approach that will actually help to make your make processing of massive data sets more easily, and allowing your specialists or experts to focus maybe on more important processes and more important tasks that cannot be automated at this stage of ML development. In the long term, I think there are a number of benefits that this can yield: higher performance, saving time, and also timely risk prevention.
Yeah. So it's really interesting, and I'm sure this would give us a real good insights to all the developers and how they should be they should be focusing on their anomaly detection skills. So here I would like to invite all the super senior developers who are willing to work remotely with the companies in US. Like we have 100 plus jobs in machine learning, data science, and if you have confidence in your skills, head on to turing.com/jobs to apply now. Okay. So David, like this has been the great discussion so far, and I think it's time to bring up our talk to a close. But before we close our talk, let's share like some of your tips and resources on how our viewers can enjoy, they can learn the MLOps skills and they can appear for their interviews using that particular resources.
Yeah. So I think there are several parts to MLOps skills. The first part is to actually understand the ML model and data science model really well. So people in MLOps maybe come from two directions. One is they are DevOps guys who are learning ML, and the other direction is they are data science or ML guys learning DevOps. And because the MLOps is kind of a mixture or at the intersection of these two fields. So understanding the ML and data science models is crucial to be able to build in the right metrics and the right pipelines and the right approach. The second part is that understanding ML and data science is actually not enough in the real world to be able to be a successful MLOps. So also having a good understanding of MLOps infrastructure, the cloud infrastructure, moving beyond, let's say, Jupyter notebooks and pandas, and also understanding how to handle large data sets and how to transform your code in your Jupyter notebook to a production grade code that can be deployed to servers is another important skill. There are a bunch of resources, I think, to learn this stuff, both if you prefer like video lectures, there are a number of resources on Udemy and Coursera. Like there is a great course on Udemy for deploying machine learning models to production. I think that was the name of the course. And there is also the practical MLOps book that is also very helpful to get started with MLOps and to make the shift from ML to MLOps as well, or to add it to your stack. Yeah, I think these would be the main recommendations, and also it's very important to understand the CI/CD pipelines and how to automate a number of your processes with those pipelines. So getting a good grip on that is also very important for MLOps interviews.
Yeah, that's really helpful. Thanks a lot, David, on sharing such valuable advice. And I hope our audience enjoyed this discussion as much as I did. So this will be a wrap from our side. Thank you so much for joining us for this MLOps interview. And if you have any queries, please feel free to reach out us at support@turing.com. Let us know in the comment section what you would like to learn in the next video. Give us a big fat thumbs up if you like this video, and do not forget to subscribe to turing.com. We will be back with many such more interesting dev talks with super senior engineers in the team. Till then, stay safe and click on the link in the description below to apply at Turing. Thank you.